All right, last problem. This is a very unit circle-y problem. Anytime you see that radical 3 over 2 and 1/2, you definitely know your mind goes right to the unit circle. So here, A is negative radical 3 over 2. B is negative 1/2. So if you start thinking about what R would be if we're on the unit circle, you might be able to go directly there. What's our R anytime we're on the unit circle? Well, you can do that math, or you can realize that our radius everywhere on the unit circle, if both are A and B, our unit circle values, our R has to be 1. All the way around. Okay, so tangent. So you can think about this in unit circle terms. If cosine is radical 3 over 2 and sine is 1/2, what's your value? What's your angle? You can think through it like that. Or you can do the division. 1/2 divided by negative radical 3 over 2. Our 2's are going to cancel. We're going to end up with 1 over radical 3, which is the same as radical 3 over 3. So if we were doing tan inverse, we would say pi over 6. Since we know both our A and B values are negative, that means that we're really in the third quadrant. So our theta value here is our third quadrant 6, which is 7 pi over 6. And now we're ready to go. Now we're ready to roll with our complex number in polar form. So all that pre-work to get this. 1 times cosine of 7 pi over 6 plus I sine of 7 pi over 6. And we're taking this whole mass to the 8th power. To apply our theorem, we're going to do 1 to the 8th. And then we're going to multiply our cosine and sine angles with 8. One to the 8th is just 1. Set 8 times 7 pi over 6. (28 thirds). 28 pi over 3. All right, well, that's wrapped around our unit circle a bunch of times. In order to figure out where that is, we need to subtract 2 pi. So go ahead and pause and figure out how many times that is wrapped around your unit circle, or just figure out what your coterminal angle would be between 0 and 2 pi. So you're going to take that 28 pi over 3 and you're going to subtract 2. So hopefully you subtracted 2 pi 4 times, I think is how many times I did it. And I ended up with 4 pi over 3. And since we had a 1 out front, we don't have any numbers to multiply in. So we just need cosine of 4 pi over 3. Cosine at all of our pi over 3's is 1/2. 4 pi over 3 is in quadrant 3, so we need a negative. Sine of 4 pi over 3 is negative radical 3 over 2. And we need our I in there. There's your final answer.